So let's just talk about the Radix Sort algorithm. So the Radix Sort is a non-comparison based stable sorting algorithm. Non-comparison based means here we do not compare between elements. And also this is one stable sorting algorithm, that means here the equal elements will preserve their relative order. So this Radix sort is to sort numbers from the least significant digit, that means from LSD, to the most significant digit or the MSD. Now suppose we wanted to sort these numbers using this Radix sort. So this is the LSD or least significant digit of the number, and this is the MSD or most significant digit. So we're gonna start sorting the number from the LSD towards the MSD. So the first step is to find the maximum number. So here that is the maximum number, and the maximum number has 3 digits. So that means we're gonna repeat for each digit. So we're gonna repeat the process for the ones place, tens place, hundreds place, and so on. So as we know, that is the ones place, that is the tens place, and that is the hundreds place. So first of all, we're gonna apply this Radix sort in this ones place position. So here 90 has only 2 digits, so here we're gonna fill this with 0. Similarly, 2 has only 1 digit, so the rest of the digit will be 0. So to perform the Radix sort, so first of all, for this ones place of all the numbers, we have to apply any stable sorting algorithm. So we can apply the counting sort. So in the counting sort, first of all, we count the frequency of all those digits. So here we have the digits 7, 0, 8 and 2. So we have to count the frequency of all those digits. So because the range can be from 0 to 9, so we have to create one count array which will have the size of 10. So here the indexing will be from 0 to 9. Now we have to count the frequency of all these numbers. So we have 1 7, 1 0, we have 1 8 and 1 2, and rest of the digits are 0. And secondly, we have to update this count array to find the cumulative count. So now we're gonna modify this count array to find the cumulative count, which will have the actual position of all the elements. So cumulative count means we have to update the count by adding the count of the previous element. So that means we're gonna add 1 and 0, so this will be updated to 1. Then we're gonna add 1 and 1, so this value will be updated to 2. Then we're gonna add 2 and 0, so this will be 2. Then again this will be 2. So this way we have to update the cumulative count of all the digits. Now we have to build this output array. So here we're gonna build this output array. So the size of the output array will be same as this original array. So that means it will have 4 positions. So this cumulative count array will help us find the position of element in our output array. So here the value is 2, that means you have to look into the index 2, and here, so here the count is 2, so we have to reduce that by 1, so the new count will be 1. That means the value 2 will be inserted at the index position 1, so the 2 will be inserted right here. Then we have the number 8, that means we have to look into the index 8, and here the value is 4. So first of all we have to reduce that by 1, so the new value will be 3. So that means the value 8 will be inserted at the index 3 of the output array. Then we have the number 0. 0 means here at the index 0 we have the value 1. So we have to reduce that by 1, so the new value will be 0. So that means the 0 will be inserted at the 0th index. And next we have 7. That means you have to look into the index 7. So here we have to reduce the value by 1, so the new value will be 2. So that means the value 7 will be inserted at the index 2. So this is the output after applying the counting sort to the digits of ones place of all these numbers. So that means 0, that means this value 090 will be at the 0th index. Then we have 2, that means the value 002, so this will be at the index position 1. Then we're gonna have this 7, So 207, this will be at the second index position, and then lastly we are gonna have 118. So this will be the position of numbers after the pass 1. So we are done with the ones place position. Now we have to apply the same counting sort for the tens place position also. So we have to repeat the same process for the number 9001. So that means we have to find the frequency of all those digits, then we have to find the cumulative count, and then again we're gonna get this output. So after applying the pass 2, the 002 will be at the first position, then 207 will be at the second position, and then 118 will be at the third position, and 090 will be at the last index position. So this will be the state after applying the sorting for the tens place digit. Now we have to apply the same process for this hundreds place digit. So this time we're gonna have the digits like 0, 2, 1 and 0. So that means first of all we have to find the frequency of all these digits, then we have to find the cumulative count, and then we're gonna have the output array. So after the pass 3, 002 will be at the first position, then 090 will be at the second position, and then at the third position we're gonna have 118, and then lastly we're gonna have 207. So we're done with the ones position, tens position and the hundreds position. So after all the passes, that means now the array is sorted. So that means this will be the final sorted output after applying the Radix sort. So let's now derive the time complexity of the Radix sort. So in the Radix sort, we are basically applying the counting sort for all the digit position. So because here the maximum value has 3 digits, so because of that we are applying the counting sort for 3 times. So suppose D is the number of digits, N is the number of elements, and K is the range of numbers. So because we are working with the decimal number, so the range will be 10 from 0 to 9. So as we already know, the count sort has the complexity of order of n plus k. So we are basically applying the counting sort for d number of times. So that means the overall complexity will be d times order of n plus k. So as the k has the constant range of 10 for the decimal numbers, so because of that k is a constant, so we can simplify this. So the overall complexity will be order of d times n, and that is the time complexity of the Radix sort. So let's now talk about the space complexity. So in Radix sort we are basically applying the counting sort for multiple times. So because the counting sort has the space complexity of order of n plus k, so because we are just applying the counting sort multiple times, so the overall space complexity for the Radix sort will also be order of n plus k. So hope you understand about the Radix sort algorithm. In the next video we're gonna explain in detail the code of the Radix sort. So hope you understand the concept. See you in the next one. Take care.